Hello, everyone. My name is Elena Carrasco, and I'm going to present on an IoT tailored, private permissioned Ethereum blockchain smart network. So, automatically, that's super loaded, but hopefully, by the end of this presentation and the demo, you'll be able to understand a little bit more about blockchains. So, we're going to go ahead and jump right into it. If I go to Google and I type in blockchain, this is what I'll get: a digital ledger in which transactions made in Bitcoin or other cryptocurrency are recorded chronologically and publicly. Okay, so the main takeaway is digital ledger. It's a way of record keeping digitally. There's a lot that surrounds this statement, but we want to talk specifically a little bit about applications for IoT, because this definition doesn't really hint that we can integrate something like IoT. So, in order to solidify the idea of blockchain, we're going to go through a real life example. I like to talk about a story where Jack wants to buy a camera from Jill. So, Jack has a form of value, currency, it could be whatever, and she has a camera and they're wanting to do a transaction. They're also inside of a room with a bunch of other people. So this is an imaginary scenario to help you understand blockchain, okay? So boom, they make the trade. We see that Jack loses money but gains a camera. We see that Jill gains money but loses a camera. What's important here is the consensus mechanism. If we look onto these ledgers, these digital ledgers, we see the state when we see that on both of these. But then we also notice that a time and date later, it's a transaction that occurred. Jack now has the camera and Jill now has plus 50. So what is important here is consensus. Everybody in the room has to have the same perception of what happened, the same data. Okay, so this is important because this is one of the main mechanisms that we're using or that we're changing to tailor to an IoT blockchain. All right, so now let's talk more on the IoT side, the smart city side, the blockchain side. If I were to propose to you three subsystems: healthcare devices, transportation devices, and smart home devices, they're commonly the data is ran through a centralized server. But the thing about these devices that make them special is that they are IoT devices, commonly low storage devices, commonly low energy, and commonly low computing power. So these are the main three IoT takeaways for me when I have to tailor something, tailor a blockchain to it. All right. So the motivations again of using blockchain is that I get to have confidential encryption. I'm using a immutable digital ledger, and this is all accessible through a distributed storage architecture. So why is this good for IoT? Is because when we use a private network, you have less data, which means you have a smaller blockchain, which means you have less storage. This is a perfect setup for a more low storage situation like IoT. Again, now we move on to proof of authority. This is the consensus mechanism. This is important because it allows this blockchain to run on a lower computational consensus mechanism. The commonly used mechanism is proof of work, which is why we know what miners are and how miners use all this energy to get Bitcoin. That's not how proof of authority works. There's very specified nodes whose job is to verify over and over and over. So that gets me to the next point. We have appointed sealer nodes. A sealer node is the equivalent of a miner in this situation. So these sealer nodes, they can actually vote to add new nodes in to their consortium of nodes that are doing the validation. All right. So again, you notice the system that I brought up earlier, but this time we're going to integrate it with the blockchain. We're making a IoT tailored blockchain. So what's important is that On any of of these devices, we can connect a Raspberry Pi, which in turn has the Ethereum node on it. And then we use our common host machine to do the mining and maintenance of that blockchain. In order to peek into the blockchain, you need to have a client with Chrome, MetaMask enabled, so that we can use the Web3 features to actually interact with decentralized applications. So that's again a little bit loaded, but when we go through the demo, hopefully it makes a little bit more sense. So first, we're going to start with the PC computer having two different directories, one the sealer node, one which was the secondary PC node I talked about, and I have a Raspberry Pi that has its own directory for its accounts. You use the following commands to initialize and create the accounts with the Geth client that I have already installed. Um, Again, we went on to the second step, which was to make the genesis.json file, which is important because it includes something to tie all the nodes together and to sync their information, which is the chain ID, which we also need to use a program called Puppet, which allows us to easily configure one of these files via terminal, which I have already done. So then we are going to set up our boot node, launch it, launch the peers, and then do a transaction and check it. So this is kind of the moment of truth where we're going to actually see our blockchain in action. So as you see, we already have the boot.key, which I generated earlier. So we're going to go ahead and launch it so that we can go ahead and sync up the other nodes and demo the communication over the blockchain. Okay, so now that the boot node is launched, we are going to need to launch the peers that we created earlier. So I'm going to go ahead and go into sealer node 1. I'm going to open that in terminal, and I've already created the script that needs to be launched. So this is the node starting up, and what we'll see up here is a ping pong effect between the node actually communicating to the boot node. And it'll show the respective port number right here, 3033, which we set up on this launch script. I'll go ahead and show you the script on the second node so that you can see specifically what I'm talking about. So now we're going to go ahead and launch the second node. Again, this first node is working as a sealer, so you're going to see it mining blocks here, mine potential blocks, and that's what it's going to keep doing and maintaining the ledger. So I'm going to go ahead and show you the launch to file. Okay, so this is the command right here. Get, and you're going to include a network ID. The network ID has to be the same between the nodes for them to communicate. And then it has a note right here, enode. This is the information that we're changing. Okay. Then you can see here it says the port number. So this port number is going to be 3034. So whenever I launch it, you'll see that it's going to start pinging this different port address for this respective node. Okay, so I'm going to go ahead and save this. Control X. Yes. Boom. And if I launch it, okay, the node's starting up. It's unlocking the account. And so you'll notice here now we're getting 3034 because that port is also pinging. So we successfully have two nodes running on this private network, and we can exchange information between them. I'm definitely going to demo that, but I'm going to show you real quick the future works area, which is the Raspberry Pi node. Let me go ahead and pull that up. Okay, so to access the Raspberry Pi, we're going to go ahead and SSH into it. I'm going to edit that file, put the correct enode information in, and try to launch this script. Okay, so I've pulled up the script for this Raspberry Pi node just so you can check it out again. Again, the same network ID. I've just replaced the E node, and then we're going to notice port 3035. Um, and also the RPC port here is different. So I'm going to go ahead and save this and send it over to the Pi via FileZilla. Go ahead and send that file over into the correct directory. Private network, RPi node. Here's the launch file. I'm going to replace it. I've repaired that file a little bit, and we're going to try this again. Okay, so it shows the configuration and the chain ID. Let's see, configuration and chain ID is showing up properly, and we're getting the URL with the respective RPC port, and it says it's unlocked account, but this is where I keep getting stuck, and the client is trying to unlock, but after that will just stop, which is the last step before the client can run fully. So that's something I definitely need to look into for future works to see how that fixes. But once that connection is made, we should be able to freely pass the data on to the blockchain. So let's go ahead and demo that. So as we begin, we see these chains running, these nodes running. What you need to check is a Chrome browser first of all, and then you have to install something called MetaMask. MetaMask is a Web3 enabled technology that allows you to interface with um, decentralized applications. So this is a website that you would not be able to see unless you had MetaMask enabled or interact with. So we're going to go ahead and go to this. This is a neat little tool where I can connect to my clients. It'll tell me what version of Geth I have, what version of Go, and it'll tell me my peer count. And right now it makes sense the peer count is 1 because that's all we have set up is this sealer node has 1 peer and the PC node has 1 peer, which is a sealer node. There's a balance of ether that gets um, configured during the Genesis block, which we did in Puppet. Okay, so we're going to go down here to compile a contract. So the contract is a simple get and set code. Set, you place it in there, and get, you put a new value. So we're going to go ahead and deploy that contract, and we're going to get a contract address. This is all happening on our blockchain private proof of authority network right now. So we're going to set a number on this first node, which I'm on, because again, this is 8545, which is this guy right here. Now I'm going to send a value, right? So we're going to set 5431, okay? And I'm going to go ahead and send that. So you'll see the transaction details, and we'll also see that commit new mining work happening down here. Okay, but how do I really know that it's on the block? If I go to another node. So the next node along is 6, so I'm going to connect. Here I am, I connected again, I have a peer count. And this time you don't have to deploy the contract onto this account because it's already been deployed on the other node. So what I'm focusing on is grabbing that information. So I'm going to get that out, get number, and I'm going to call return 54321. So it was successful, and this is the correct value that's stored on this proof of authority network. So this is as far as the progress that I've been able to make over the semester. If you have any questions, please don't hesitate to reach out to me, and I hope you enjoyed the demo. Thank you.